For our last and final lesson, this is, I'm going to say, from the last time I taught middle school math, this was a 7th grade lesson, but this is something that even my AP Stats kids work on. So you have to be able to analyze information. And whenever we are analyzing information, you need to know some things about it. You need to know the certain range values are acceptable in, because if you have data that you have an idea of what you expect a value to be. So like on this one it says the average height of an adult male in the USA is 5 feet 9.2 inches. All right, if you were collecting data and people were measuring the height and all of a sudden somebody was, I don't know, like they wrote down that they were 13 feet tall, what would you think? Like just knowing that the average height is 5 feet 9, if someone says they're 13 feet tall, okay, you would say they were a giant, or would you maybe think that they made a mistake? All right, but whenever you see a number that's way out of the norm like that, you have to question it in some way. Those are what we call outliers, which we'll talk about in just a little bit. But whenever we are going through these, we're going to first, you have to know some information before you can make those you can make those assumptions like, is a certain answer reasonable? Being able to analyze data is probably one of the most useful things in life, because how many times do you guys read articles and you're given a statistic and you're like, is that really true? Like, do you guys ever feel like you're skeptical about articles that you read ever? Or do you believe everything that you read on the internet? I'm just asking a question. You guys believe everything you read, or are you skeptical? Okay, I'm like, every time I read something, I'm like, I look to see like, okay, where they get this information from. I always try to make sure that it comes from something that is an accurate source of information. And so, obviously, you need to know range. Sometimes it depends on the type of information. If we want to use like averages or medians, sometimes the mode is very helpful. Say when people take a survey and they're making, like whenever they say like majority rules, they're collecting data and using the mode, like whatever the most votes is wins. That's a mode. And so we're going to go through this. We're going to talk about how to calculate mean, median, mode, and range. And then we are going to talk about tomorrow how to construct box plots and finding that 5-number summary. But we'll see how far we get today. My goal is to get through everything today so we can just do box plots tomorrow. All right, so average is just a word that we use to summarize a set of data. When you guys think of average, what do you think of? Like if someone tells you that the average, like if I told you guys the average on the last quiz was a 75%, what's that mean?
Well, that was the most consistent score.
You know, say the most is actually the mode. Whenever you're talking about average, anybody else have any or have any association? If someone says it's average, what do you think? Yeah, it's an overall assumption. Like, yeah, I can kind of see like an overall. I say, does anyone think of it as like the middle? Like if you're average at something, you're not extra great at it, you're not terrible at it, you're just kind of in the middle. And so average is just something that we use to separate, and it's something that we can do about an entire population. And anytime we are talking about the measure of central tendency, so when we are talking about the center, we are talking about the average. Now, out of these words, mean, median, mode, which one means average? Mean, median, or mode? Which one is the average? The mean is the average. Now, the median is honestly, if you list everything from smallest to largest, the median is actually the absolute middle number. Mean and median are not always the same. And when we're talking about the mode, we're talking about the most. So the mode, and if you look over here at these examples, when we're finding the average, we are just adding up all the values and then dividing it by the number of values. That's the one that you actually have to do some calculations. I know that whenever I taught middle school math, I always just told them, remember, mean is the average, because you actually have to do some work. And I'm mean and I make you show all your work. So whenever you're finding the average, you are going to calculate. So if we have, this number listed up here, you add every single one of these, and since there are 8 numbers in the list, we divide by 8 and we get an average of 4. Now in the median, we list them in order. Make sure that you actually have this like highlighted, boxed in, circled, put a star beside it. In order to find the median, you have to have your terms or your data set in order. I always put mine from least to greatest. And so it's the absolute middle. And if it's an even number and you have 2 numbers that share the middle, we just find the average of those 2. Find out what's in the middle. And then on the most, if you guys look at this list, the numbers that you see the most frequently in this list, 1, 2, 3, 3, 4, 5, 5, 9, you actually see 3 and 5 more than once. You can have more than one mode. So we are actually going to find the mean, median, and mode of this example down here. All right, so the first thing I want to ask you guys, are these numbers in order?
Yeah.
All right, how many numbers are in this list? You just have to count. How many numbers are in this list? It'll be helpful for us later. So if you count, how many numbers are there? Count them all. You guys tell me when you're done counting. How many did you count? 15. Okay, so when you are finding the mean, we are going to add all of these up and divide by 15. All right, so we are going to find the sum of those numbers, and then we're going to divide it by the total amount. So the first thing, and you guys have calculators, or you can just count this by, so 0 plus 0 is 0. So we've got plus 1 is 1, plus 1 is 2, and then 4, 6, 8, 10, I counted by 2s, 13, 16, 19, 22, 25, 29, 33. So when you add all of these together, we add them together, we get 33, and then we divide by 15 because that's how many numbers there were in the set. So now you guys have calculators. Let's take 33 divided by 15. So what's our mean? 2.2. All right. Now let's take a look at, I'm going to write on something for the median. So actually, let's go over here and look at the mode first. We'll go back and do the median in just a second. Out of all of those numbers, which one do you see the most? I'm going to say 1, 2, 3, 4, 5 threes. That is, you see 3 the most frequently, so the mode is 3. You know, say there's really no work there. You're just looking at it and telling me how many that you have. Now, if we would have had 2 numbers that were the same, we would list them both. You can have more than one mode. All right, now for the median, we are listed from least to greatest. So I tend to I use fingers or I will mark them. But if you start from the outside, put 1 finger on the lowest number, 1 finger on the highest number, and then just kind of count in until you get the middle number. Which one is in the absolute middle of the list? 2. All right, now on this one there's 15. What's half of 15? 7.5. So on this one, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. You always want to make sure that it's right, split down the middle. So if you know that halfway is 7.5, so you're going to look the first number after this, so it'd be the 8th one that you would look at. So on that one, the median is 2. How many of you guys think that you could do that on your own?
Isn't there one called the range?
There is one called the range, but we're not going to talk about the range right at this moment. The range, we would actually just take the biggest number minus the smallest number, and in this case, 4 minus 0 is 0. And I'll say if you want to write that, you can. We'll eventually get there. So the lowest number is 4, the high number, 4 is the highest number. So 4 minus 0 is 4. I'm going to say we will eventually get to the range. We do a lot of range with box plots. Now this next table, the first time I looked at this, I was not really for sure what it was asking, but it took me a second. All right, so I am actually going to, I'll say, I'm just rewriting those because it's a little hard to see on this black and white. All right, now it's showing up, not too bad. All right, so what this is telling us on our table, it's showing us the number of trees in the yard of each house on a street. So what this is telling us here, this very first box, all right, the number of trees is 3. It is telling us that 1 yard on this street had 3 trees. Does that make sense? The next number, this 4, 5, it is telling us 4 trees in the yard, but there were 5 yards that had that same amount. So what this is telling us, if we were to make this as a list, it just means that there's 1 3, but then there are 1, 2, 3, 4, 5 yards with 4 trees. So if you wanted to make this as a list, it's telling you there are 5 4s. Now, how many yards had 5 trees? Look at the table. How many yards had 7 trees? So we would actually put 1, 2, 3, 4, 5, 6, 7 5s. All right, how many yards had 6 trees? 4, so 4 sixes. How many yards had 7 trees? Just 1, and 8 trees. There were 2 yards that had 8 trees. So this would give us the total number of trees on the street. So the first thing we want to know is the average trees per yard. So these numbers here tell us how many trees there are. So the first thing we need to do is add up the total number of trees, and then we're going to find out the average of trees per yard. So let's add all of these up. 3 plus 4 plus 4 plus 4 plus 4. Add all your 5s, add all of your 6s. Now I've added this up already, but I want to make sure that you guys get the same number. So let me know what you get when you add up this list of trees. I like that number. On this street, there are a total of 105 trees. Now, how many yards were there in total? That's how many numbers are in the list. So if you count all those numbers up, how many yards are there? 20 yards. So whenever we added those up and we divided by 20, are we finding the mean, median, or mode here? This is the mean. So 105 divided by 20 tells me 5.25 yards, and we don't have to round that since it's not a repeating decimal. So it says on average 5.25 trees per yard. I'm trying to think now how many trees I have in my yard. Which I don't know, I can't really count, like there's like an entire line of trees that divide my house and my field. So I wouldn't really count those, but there's like 3 pine trees in the back. I have 2 trees in my fenced-in backyard. And then I have 1, 2, 3 in the non, so 3, 5. I have 8 trees. How many trees do you guys have in your yard?
Like,
Sit.
at least over 100. No, I'm serious.
4.
Or maybe closer to 75.
So do you guys think this is a city street, or, you know, do you guys think these are a county road? Do you think this is a county road or a city street?
City street.
More than likely a city street if the maximum is 8. All right, so that was the mean. All right, we've got to do median and we've got to do mode. All right, so let's think about this. If there are 20 yards, if we split it right down the middle, how many, like if we put it down the middle, how many trees would be on each side? Or how many numbers in the list? If there are 20 yards total, what's the middle? What's the middle of 20? All right, so on this one, since there are 20 yards, we could start from here and count in until we have the middle, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Would that split that in 10 yards on this side, 10 yards on this side? Is that? All right, now, whenever it splits, if there is a number that's not exactly in the middle, the 2 numbers that share the middle, you would take the average of. But what's the average of 5 and 5? 5. So this one, the median, what's right in the middle, is just 5 yards. Or 5 trees, sorry. And then the most is the one that we see, the mode is the one we see the most. What was the most popular number of trees?
5.
Yep, 5 yards in the middle, 5 yards that we see the most. All right, so we are going to talk about outliers. Now, on those last lists, the numbers were all pretty close together. Like we didn't have anybody, all of the trees in that last yard were anywhere between 3 and 8. There wasn't somebody that had 100 trees on this table. There wasn't anyone that was out of the norm. So an outlier is something that is substantially different. So it's just way different than the rest of the set. And so if we look at these test scores, look at all of these test scores right now. If I wanted to do the mean out of this list right now, I would add them, and then what would I divide by? How many test scores are there? 7. So let's add these and divide by 7. So we're going to take 87 plus 76 plus 86 plus 79 plus 90 plus 14 plus 85 and divide it by 7. So when you add all of these up, what are you getting? I have a number, but I want to make sure you're adding correctly as well. 517. Divide that by 7. And I am getting 73.8 or 73.9 because the 5 would tell us to round up. All right, so that is the average of this list. Now, I want you to look at these, and maybe it helps if we list these in order. I think this is a little bit easier to see. So the average of this list is 73.9. Do you think out of this list, are any of them an outlier? Are there any of these test scores that are just substantially different than the rest of them? Say, this 14 is nowhere near all of these. And so whenever you do that, if you have a number that's just way out of the norm, it really like on this one, that 14 really pulled down the average. It says the average is 73.9. But everybody but one is above that number. Typically we like averages to be the middle or around the middle. And so whenever you have an outlier, it affects the average. So we definitely think that 14 is the outlier. Now let's pretend like we throw that number out. What would be the new mean of these? All right, so you guys can re-add all of those, or think about this. If the original list added up to 517, if you take out a 14, what would be left? If you took out 14 out of 507, so that would actually be 503. Now you could re-add those, but now how many scores are, it's not out of 7, it's out of 6. So 503 divided by 6. This time I get an average of 83.8. Do you think this looks more like a representation of the scores that we see here? So which one do you think is the better mean? or which one represents the class average better? The one with the outlier or the one where we took out the outlier? Say sometimes taking out the outlier gives you a better representation. So that's why being able to analyze data is so important, because if you can recognize those outliers, you can see that sometimes, like maybe you're reading something in the news and they don't take out those outliers, so it makes the average look a little weird. Say one thing that always kind of drives me crazy is whenever they compare education in the United States around the world, and they will be like, oh, the United States, kids are testing so low compared to other countries. Well, we educate all of our children all the way until they're 18 years old. In most European countries that they compare us to, those kids, whenever they're 13 or 14, they have to choose, are they going to do like an academic route where they go to more of like a traditional high school that we see, or do they go to a trade school? They're making those decisions at 14, where we don't have our kids make that decision until 18. So whenever you're comparing test scores, they're only testing the kids that choose that academic route. We test everybody. So do you think that's a fair comparison? Say that one only, I was like, we test everybody. We even test the outliers. And so therefore brings down our average a little bit whenever we compare to other countries. Now, we can ignore this second part, but answer this. Out of these numbers, which one looks like an outlier?
42. 98. Just kidding.
Hey, why did we not want to pick 42, Lane?
Oh, I thought it was the last number.
Well, look at the list. Do you even see a 42 there?
Yeah.
So make sure if you are looking at this data set, you can only pick numbers that are in the list. So 42 is not even in the list, so we can't answer that. Now, out of these, which one is out of the norm? 98. Very good. I'm going to say, do you guys have any questions on this?